All right, so this is James in my presentation on the thin client deployment, or known as the thin manager as well. So to start off, what is a thin manager? Essentially, a thin manager is the brain of your network. It handles multiple things at once. Some examples: users, permissions, devices, software's visualization, hardware, and it interacts with your production environment. So, like I mentioned, it's the brain. It handles everything and anything that you need it to handle. The nice thing is that this thin manager is essentially works as a team, as if you had a whole team specifically designed for each of these components. So you don't have to worry about having tons and tons of employees. You're able to do everything with the thin manager and be very efficient. The other thing that is very nice is that it handles all your updates and all your maintenances for your softwares. So it's, like I mentioned, the brain, it does everything. The other nice thing about having this server is that if you have an end device that goes offline, if someone attacks it or whatever the case is, a Thin Manager can replace it right away so that there's no gap in between your production environment or whatever you're doing in your environment while you're able to remove the device, do diagnostics, do whatever you need to take care of it. Like I said, this replaces it right away, so it's makes it an easy process. So how to use a Thin Manager? uh, the things you'll need is HTML5. It's the protocol that they recommend. They also recommend a cloud application, your standard OneDrive, Azure, iCloud, whatever kind of cloud database you want to use. And then Rockwell also recommends doing geofencing. And the reason for that is that Thin Manager can be used on mobile devices, on tablets, not just computers. So really anything, and you want to make sure that your environment is secure. So geofencing is one of those ways. Here I have a snippet of the YouTube video clips that they give out. And right here, I put on here, it shows that this is the software that you use that you interact with. They make it very, very simple. As you can see on here, it shows that they clicked on Thin Manager Server and it gives them a list of things that they can and can't do. Very, very user friendly, which makes it great for anyone that needs to use it. Also gives a vulnerability because if it's so easy that anybody can use it. But ideally, your network is secure enough that you don't have to worry about those things. So what you'll need, a segregated network, which is the biggest thing, being that this thin manager is essentially your brain. So you want it to be protected. You want to have your multi-layer switches, communications up and down from different layers, firewalls, policies, your standard security practices. Rockwell also recommends using the encryption software that they have, which is the AES 256 encryptions. And then based from Rockwell, the different ports that you want to use is your UDP 490, which is for your TFTP downloading of the firmware, TCP 2031, which is configuration, TCP 2032 is your proxy service for like iPads, iPhones, things like that. UDP 67 is your IP address, and then UDP 69 is used for your PXE server, or 69 and 67 can be interchangeable depending on what you want. Then TCP 1494 is used for your ICA protocols if you're using ICA. And TCP 3389 is used for your RDP protocols if you're using RDP instead of ICA. And TCP 5900 is for shadowing. And then you have your UDP 1758 is used for your default multicasting. So those are the kind of ports that they recommend that you utilize as much as possible. Now, as far as for communications, Like I mentioned, you want your multi-layer switches, you want to have your firewalls, your VLANs, and your subnets set so that everything is segregated, everything's nice, and everything can communicate. Now from here, oh, let's go to oh, there we go, our architecture. So we have our internet here. It comes into our router, then goes to our firewall, and then here is the enterprise network. Um, so our layer 7. From here, you have your switches. Then they go to another firewall, and then our other core switches into our layer 3, which has our multi-layer switch here, and then thin manager. This is a very, very simple diagram, very basic. And then from here, it'll go down to our multi-layer switch for our layers 2 through 0. And from here, you can have it on as many end devices as you want. Like I mentioned, it being the brain, you want it to be connected to anything that you're gonna want to use it for. So like I mentioned, it's a pretty simple diagram. It just sky's the limit on how you want to use this. So really, however you and your industry sees fit, it's basically how you'd want to use it. Let's go back to here. And now from here, James will go ahead and do his part. Go ahead, James.
All right, can you hear me?
Yep, you're good.
All right, so kind of a brief overview of a little bit more of what a thin client setup is. So it's where a thin client setup in network security is referring to computing architecture where basically all of the processing and storage is done by a central server. The thin clients are usually lightweight and typically have minimal processing power, memory, and storage capacity. So an example of that you could say is like a Chromebook. It's a thin client to the Google server. Um, so because the thin clients rely heavily on a server for basically doing everything, um, this architecture has a couple advantages in terms of network security. Because of the centralized control, it's easier to implement and enforce security policies. This can include access control, data encryption, monitoring. There's also reduced attack surface because the thin clients have no local storage or processing capabilities. There's fewer attack vectors. You can't really use the thin client device to attack the network as easily. This reduces that potential points of vulnerability. Because of data centralization as well, it's easier to implement robust backups and disaster recovery procedures. It also reduces the risk of data loss or theft from an individual client device. It's also easier to update and patch manage because software updates and security patches can be applied centrally on the server. It means that all of your thin devices will have the same software version and they will all be up to date. It also has simplified endpoint security. Since thin clients have limited capabilities, there's less need for a complex security solution. This can mean that there are simpler and more cost-effective security management options. However, it is also essential to note that thin client setups also have some limitations and have some security considerations. For example, since they rely heavily on the central server, they also rely very heavily on your network connectivity. So you need to make sure you have a robust and reliable secure network. Additionally, securing the central server is critical, as compromising that server could impact all the devices within that thin management system. Next slide. So creating your thin client, creating a secure connectivity setup for your thin client has a couple different considerations to ensure data security, reliability, and performance. Again, we need, like we talked about before, you need to have some network segmentation to isolate the client devices from other industrial devices in the network. This prevents unauthorized access and limits the impact of potential security breaches. You want to use VPNs. Uh, uh, thin client devices to the corporate network or the centralized server. This ensures that the data transmitted between the clients and the network is encrypted, and that prevents that interception from unauthorized users. You also want to make sure you have your firewalls to control and monitor traffic. This ensures that that data leaving and entering the thin client network is known and can be prevented to only what you allow. You also want to have your intrusion detection and prevention systems to prevent any suspicious or malicious activities and detect them if they do happen. This just adds an additional layer of security by continuously monitoring your network traffic. You also want to have access control lists. Having strict access control measures can prevent the thin client devices to only authorized personnel. This can include user authentication mechanisms, like passwords, biometrics, smart cards. You also want to have your endpoint security. You want to make sure you have antivirus. So antivirus and endpoint security software on your devices to protect against malware and other security threats. Even though there's very little processing power in these devices, it's still a good idea to have that implemented. Again, you want to make sure that you regular security audits and updates. It's a lot easier to keep these things updated through their central processing, but you still need to make sure you stay on top of that. You also want to make sure that your physical security is in place because of that central server's importance in your system. Maybe using locks, camera systems, key card access, or an access control systems in sensitive areas where these devices are deployed. You also might want to have some redundancy and failover to ensure that your system is uninterrupted and for some redundancy in your thin client connection. This can include redundant network links, backup servers, failover configurations to maintain connectivity in the event of hardware or network failures. By implementing these measures, you can create a secure connectivity setup for the thin client devices within the plant-wide area of the industrial zone, protecting sensitive data, ensuring reliable operation. Go ahead, next slide. So connecting your thin client, your thin manager to the internet, to do that securely, there's a couple different ways to do that. You're going to need a robust networking infrastructure with your appropriate security measures. So a couple things that we can do. Like I've said before, you can have a VPN, firewalls, have your authentication and authorization. You can also segment your network based on location, department, level of security. You also may be able to separate them for public-facing services, internal resources, and sensitive data. The VLANs will isolate that traffic and restrict access between your zones. You can also have secure remote access to your thin clients. Configure your thin client devices to support secure remote access protocols such as SSH or RDP. This ensures that remote access is encrypted and authenticated to prevent unauthorized access to your thin client endpoints. You can also utilize centralized management tools to oversee and control your network access, user permissions, security policies, and implement security monitoring solutions to detect and respond to any suspicious activities or security incidents in real time. You want to keep your networking environment and thin client devices and other infrastructure components up to date with the latest security patches and updates. Again, just if you keep up to date on your patches, that will be a big step in making sure you're secure. By following these steps and adopting a layered approach to security, you can securely connect the thin client to the internet and access different cell zones while minimizing the risk of unauthorized access or data breaches. So for policies in thin client architecture, the devices are heavily reliant on that centralized server for processing and storage data. Some policies are essential to ensure that there is efficient operation, security, and compliance with your laws or company rules. So here's a couple things you can think about. Having some access control policies, implementing access control policies to regulate which users and groups have access to specific resources and applications on the centralized server. This includes user authentication mechanisms, multi-factor authentication, and role-based control to enforce least privileged access. We also have some data security policies to safeguard sensitive data on that centralized server and when that data is transmitted between the servers and your thin client devices. This just may be encryption protocols for transmit and at rest. This may also be some loss prevention measures to prevent unauthorized leakage of sensitive information. You want to have some network security policies. You want to define your policies to protect against unauthorized access, malware threats, and other security risks. This means firewall rules, intrusion detection systems, antivirus software, or regular security audits, and prevent to identify and remediate vulnerabilities. You want to have endpoint management policies to you establish these policies for managing and securing thin client devices, including configuration management, patch management, remote monitoring capabilities. This ensures that all your devices are up to date with the latest software and security patches. This minimizes your risk of breach. You want to have user behavior policies. You want to educate your users about acceptable use policies and practices for using your thin client devices and accessing these centralized resources. This may include guidelines for password hygiene, social engineering awareness, and safe browsing habits to mitigate the risk of insider threats and unauthorized access. We want to have some compliance policies, ensure that you're compliant with regulatory industry standards and rules within your organization. You want to develop these policies to address specific compliance obligations related to your data privacy. Disaster recovery and business continuity policies. You want to develop some policies and procedure for disaster recovery and business continuity to minimize the impact of disruptions on the thin client infrastructure. This includes regular backups of data, failover systems, and redundant server configurations, and a disaster recovery drill to test the effectiveness of these recovery procedures. You want to have incident response policies so that your people know how to react to communication chain when there is a breach or an incident in your system. If you want to define your roles and responsibilities, escalation paths, communication protocols, and ensure that there's a coordinated response to these security incidents. By implementing these policies in a thin client architecture, organizations can mitigate security risk and ensure compliance with the regulatory requirements and optimize the performance and reliability of central computing environments. And let's see. Okay, so subnetting a thin client architecture is crucial for efficient network management and security because centralized server hosting applications and data thin client devices such as terminals or workstations access these resources remotely. Some subnetting things you can consider. Separate the subnets for departments. Like I said before, you can use VLANs. You can subnet based on their location. If there's multiple buildings within your, like if you're running off of a campus, you could break it up based on what building they're in. You can also do it based on your security zone. Like if you have some data that's need to know, that could be on its own VLAN. For example, you can also separate the subnets for demilitarized zone, internal networks, guest networks. Then you would implement appropriate firewall rules and access control between these zones to enhance your security. You also can do subnetting for quality of service. This allocates subnets for voice, video, and data traffic to prioritize critical applications and ensure optimal performance. You also want to make sure that you can use subnet to allow your thin client to expand. So if you may add buildings or you may add departments in the future, you want to make sure that your network is set up to do so. Through centralized management, you also want to make sure that you have centralized management for IP addresses, subnet configurations, DHCP, and DHCP servers, and streamline the administration tasks to ensure that there is consistency across your network. By implementing these subnetting strategies, you can optimize your network performance, enhance your security, and streamline your network management in a thin client architecture. And that is the end.